what do we do at Solvedex? Mainly, we're working with partners to train ML and AI models for them. So whether it's off-the-shelf models, LLMs, GPT, DeepSeek, what have you, or more proprietary in-house systems that require a bit more data and refinement. So doing that, as well as operating like fractional teams in order to optimize certain parts of their application and bring product to market faster, as well as scale. So as part of that, as I mentioned to you, one of the things that I was able to do is actually spin off basically a completely separate design agency with some of the foundational principles that you're seeing here. And with my own experience with design, it just so happened that what we were doing in terms of how we actually bring design and experience to market was also getting greatly affected by the shift to AI and the inclusion of AI. And so these were some of the principles with which I started in order to make sure that we could actually deliver value. So kind of at a glance, if you've taken a look at any design system before, including Google Material as an example, you're going to see your basic infrastructure, building blocks, complex patterns in order to create basically consistency across the experience. And so, when you go down deeper levels, you're going to see maybe higher fidelity patterns, which make sure that applications look, function, and feel not necessarily the same, but consistently across different multiple platforms. And going one level deeper, you get into the strategy side of things, where you actually plan for what is the long-term evolution of the system, where it can change completely or even get ready for a full-on redesign. And more importantly, in my opinion, how do you actually sunset things and move on to the next platform completely? So then what is the missing aspect here, which I've found through our work with our partners, is that most of them, being that size of small, medium-sized startup, simply don't have the personnel or the maturity within a particular niche to actually adopt this and basically implement this in an effective way. And so when you do things a little bit ad hoc, it tends to add up, and that ends up being tech debt, shows up as design debt, and not a happy customer, essentially. And throw in humans in the loop and AI, that all of that gets much worse. And so, I was working with our VP of design to come up with some of the core principles. So, and he's somebody who's extremely experienced with aspects like cybersecurity and having worked with traditional AI models well before the boom period. So we've been thinking about for the longest time, what are the principles that are most important to establish customer trust and establish that agreement between the user and the system, and how do you then go ahead and make sure that that is established through the experience and the product at all times. And yeah.
Sorry, I just want to clarify. What do you mean by design systems?
Design systems.
Yeah.
So you're familiar with the concept of user experience?
UX, so you're talking about UX?
Yeah, UX, product design. Yeah. So, but that is a good question. And so basically think like, design tools, Figma, Photoshop, anything like that, right? So design systems, if you were to boil it down, they kind of live in as Figma components, or, like a design documentation where I say, standards, like you always use a certain font size, right? You always, for example, talk in the third person as opposed to the first person. So even things like copy text, so that everything is consistent, right? And so when you use that for a product, so you're basically designing experiences, that Figma document then becomes the software that the.
So you're developing Figma-like tools for your customers.
That's one of the things, but that's just a tooling part of it. So when I deliver a design, really the way I consider a design delivered is that it is a product in your hands. So it could be a mobile app, it could be a web app. I'll actually also show a fun example where we actually even worked in retail grocery shopping. So it's in the actual product physically that you're interacting with. Yeah. Software, digital, but as I mentioned, we've also delivered physical products, not necessarily in terms of like hardware, but more so in the experience of what you use with the physical product.
So, but let's say somebody is trying to improve their software. Hello.
We have actually done that too. Yeah. Yeah. But it wouldn't, we wouldn't necessarily have a design system for that. All of this is mostly for complex AI-based systems. But yes, it is a valid question. There would be slightly different system that we would use for that. So one of the key concepts that always starts with and kind of ends with is the trust as to establish that, right? So whenever we see, this has always been an ongoing conversation with any software to begin with. And so establishing that trust has been key. And I think that, over the past 20 years, we've managed to solve that to some degree, but now we've had a different challenge. And key to it is mainly the fact that you often don't know how a model works. And especially when there are multiple models, that becomes that much more murky. So it's all about creating, because design, good design is all about creating almost like predictability. We use predictability in the bad term sense, but it's not bad when your car works as expected, right? You just push a button and it does what it says, right? So that's always good. But when you add a model that you don't quite know how it works, and obviously it's proprietary, then it starts to reawaken that challenge all over again. And and as we mentioned before, the human in the loop kind of becomes the most critical component as to why kind of all of this is happening. And the main thing is that a lot of the times our users essentially end up like quality trainers, right? Like they're either training the model or the system itself to become better. They're supplying the data or refining. So they're doing some level of QA QC. Now, sometimes it's obvious that you've hired quality trainers, and that's what a lot of our partners do, because it requires that specialized work in order to get done. But a lot of the times it's not that obvious, because it's essentially the product is already on the hands of the end user and they're providing some real world data. And we do this a lot of the time. However, depending on the type of product, so sometimes in a B2B context or an enterprise product, a good example being like a healthcare product that we worked on. So we have people who, it's not their job to actually train the AI, and yet what they do kind of becomes the training set for the next run of it, while they actually have delivered something for the ultimate end user. So as part of that, progressive disclosure becomes extremely important. So as you build up the maturity of the output that you're giving, that's a key thing that needs to be shown in a way, or at least the user needs to be informed in a way that they have the capability to make the right decision. And then, there's one of the biggest challenges is always your system is kind of like a mechanical Turk in the beginning, or at least the partners that we work with, where it's mostly humans doing the thing that has been promised to be automated. The end user doesn't always know this, but it's just a lot of manual work going on in the background. So you plan for that automation, and you don't quite know how far along that you'll get. So, which means that there's always a human in the loop, whether you kind of want it or not, right? And the other thing, kind of by definition, is that design systems are meant for humans. Like they were designed by humans for human consumption. So then how do you start subtracting parts of the system without completely affecting every other thing? So that's one of the key aspects which comes to mind, right? So one of the case studies that I'll start off with was for contractor management. So our partner, think like home repair. So you're in an apartment or a condo and something breaks, like an electrical connection, or you need a new roof. You call up your property manager, if you're renting especially, and they call up the contracting company, which takes care of the repair for you. So on one side, we have an app which is kind of like Uber for home repair, where you can just kind of put up your hand and say, hey, I'm ready to do this. I mean, you have to be registered on the platform and your skills have to be validated, but for the most part, it's almost as easy as that. So in the back end, you then have essentially estimator and back office people who are working kind of nonstop with these contractors to figure out the best kind of routing for them in order to make sure that they have a steady stream of jobs, so they don't have to always look around other places to get their income. So essentially creating a schedule, again, through running a AI algorithm, or some kind of. So when I say AI here, you can kind of substitute it depending on the use case for machine learning or computer vision. So a lot of it really depends on it. This example also happens to use LLM, where we actually use GPT and we adapted it. But so that was one of the key aspects of that experience. But for the scheduling algorithm itself, that was something that was proprietary used for that. So the challenge, as I mentioned to you, was a lot of different types of repairs to be done. There needs to be consistency with how something is quoted. So if you say I'm replacing 2 switches, we found out that sometimes it's quoted at $50 or even at $500, and that shouldn't happen, right? So doing that at scale while providing a good schedule for contractors so that they do their work and they get their income. So it's consistent and predictable for contractors, consistent for back office folks, and using that. So this is one of the interfaces where, as an example, this is basically an intake form, right? You would type all of this in. What is the problem? What kind of problem is it? Electrical, roofing, plumbing. So now that's been replaced essentially where you can do a voice input. So the human input goes away and there's a level of automation that's added, but you need to prepare for the fact that it could go wrong and it can sometimes come back with weird answers, and being able to predict that is a huge thing. But on the other end, there's another system that we built out where, for example, depending on the state or county you live in, you require different kinds of permits. You sometimes require master plumber licenses and so on. And so that process of getting permits and approvals became much faster due to the fact that you're now creating consistently high quality inputs for the county to process. So that was one of the biggest drawbacks. So now through this design, again, the design system here comes through the fact that you created these visual assets which become kind of the web app or mobile app that then already include the fact that it's AI implemented. There could be a human and it could go wrong. So there needs to be a way where things can be corrected very quickly. So let's get back to a faster, consistent solution. And that then brings us to the kind of the next level of how it is, which is really the design delivery system. So you had design systems, which, as I said, you could boil it down to those standards, visuals, components. But the delivery system now includes design ops. So that's a big thing that's going on in the industry, where you talk about how you work with not just one designer, but 100 other designers. So just like DevOps, you have design ops today, which is a mature field, and then you have to combine it with product strategy and know that for example, like we plan for the automation, expecting that certain systems will be completely taken over by the machine, which is actually good. But we also know that we don't really know which ones those are. So you need to have a evolutionary plan where it slowly gets taken over with the fallbacks that we just mentioned, but not all of them will actually be automated. So you still need human input, which means that the machine output at one stage can then have to be translated by a human back and fed back into the system. So that looping system is extremely important for this to actually work.
Just a basic question.
Yeah.
I'm just trying to understand what the artifacts are that you're building with AI and ML. And so what I'm hearing is that you're taking this LLM and you're using it, and then use case that you presented,
Yeah.
generate a detailed bid.
Yeah, exactly. A repair bid and a quote. So the customer can then approve it or deny it or make some adjustments.
That's kind of bespoke to that particular.
Correct. And it's taking that bespoke and making it the normalized pattern as much as possible. Like for example, if a roof replacement within a certain square footage, you can be pretty accurate in your assumption, especially if you're replacing the whole thing. So it doesn't tend to vary that much.
So then does this go away and it's replaced by more of a voice to
Exactly.
voice to quote?
Exactly, right? So it's like it could be 2 buttons, and at the end of it, you get a PDF, which is a quote, right? So all you have to do is make sure to have enough levers so that you can manipulate that.
I understand.
I have a question regarding that. So even if it was a standardized repair, I
Yeah.
would imagine that the model would have to have some fine tuning in order to assess what the replacement of a cabinet would cost according to the market price of carpenters in San Diego. What I mean?
Absolutely.
So I don't know how it standardizes that particular bid.
Yeah. So with the exact situation you described doesn't quite fall under repair, since it's more like home remodeling.
Oh.
So when it comes to, and that's the other, problem with all of this, is that the guy who's getting the repair doesn't care whether it's AI or people. He just wants it to be done fast, right? So for us, it's making sure that the investment in whatever LLM that we're making is justified by giving a mature enough solution that can then work across different use cases, different states, and while having very few exceptions, right? And as we do more and more of that, then the system gets better. And that kind of comes back to, yes, the human then comes back and essentially acts as a quality trainer, even though they're not intending to, right? So this is one of those cases where there's not a higher quality trainer, but they are in fact improving the model. Yeah.
So what you're saying is we use a foundational model,
Correct.
the foundational model,
Yeah.
and then it's up to the particular data, take an example, Meetup San Diego, he wants to get a permit. So you are going to extract the data from the Meetup San Diego, and then they need to fine tune it, or you are going to.
No,
fine-tune
the
it?
company that's handling this fine tunes that.
With its own data.
Correct. Yeah. Yeah. So next case study will address more of the kind of case where there's an actual quality trainer. So this is an interface that is meant for a quality trainer, also called an annotator. And this is kind of the use case of retail and grocery shopping, where the company wants to learn more about its customer shopping habits, what kind of products they're actually shopping for, how much inventory are they managing, what needs to be restocked, so that they can make better decisions about customer behavior and kind of reward loyalty and establish better practices, right? So that's going on in quite a few states. And as part of the system, basically, you're trying to identify through the video, as an example, what the customer is doing. So essentially, one person's like shopping journey has been mapped out, and the AI system has actually stitched up all of the parts by timestamps, because there's about 100 cameras in the store that they're using at all times, more like 1,000 to 2,000. So they know each aspect. So the video detection is already there, which is good enough that they've already stitched together, a full length kind of shopping journey. So now it's up to the trainer to come in then and identify which products are they picking up, right? Which products did you not, you picked up and put down. We want to understand and identify why is that. So as you can see, the kind of the purple boxes are what's basically bounding boxes. So those are the boundaries for the different products that have been automatically identified. And so it's up to the user to not only model these actions and label these actions, but also identify products. So if a product has been misidentified, let's go ahead and correct that. If there was something that was picked up that was kind of unusual, let's go do that. And one of the problems that this introduces also is, what if you have two people shopping? And what if you have up to like a family of 8, everybody's shopping? How do you then collect all of that data together to understand what is the shopping behavior of an individual versus an entire family? How does that change, right? So you need to be able to do this where there's already multiple parts which have been automated away, but you don't know which is which. So it really is important to have a transparent system that tells you that you did some action, but then the system came in automatically and improved upon that action, or maybe you decided to override that. So that kind of disclosure is extremely important, and that's kind of the change log that you're seeing here. And then the user can go ahead and mark it so that, as I mentioned, we can accurately track behaviors and use the advances within, here it's not really AI, it's more computer vision and just machine learning, and use that for, as I mentioned, like the major retailers are using the system to bring better products and take off less profitable ones, as well as improve checkout times. That's been a huge improvement as well.
Radius. Excuse me.
Yeah.
In terms of, because these kind of models where they put set up across.
Yeah.
And all these things, for example, Amazon.
Exactly.
They already have this type of. How do you? No. Excuse me. What's the value addition on the top of like what you've been doing? Because I need to start from if I understand correctly, I need to start from scratch, right? In this case, for example, I'm a small business owner. It's like a local grocery shop.
Yeah.
Okay, I need to, in order to train, fine tune my, I need to, start organizing all the, the things and and then basically build my own, design my own, data collection methodology, and then fine tune it, and then there is a lot of work, but where your model stands in terms of the actual value addition
Yeah.
compared to the standard like Amazon Fresh.
Yes. So Amazon Fresh, I will let you know, it actually shut down because of the fact that they have a very strict way in which they work, and it just doesn't work for literally anybody except them. And one of the things is, for example, if like you decide to buy potato chips, there it always has to be in a certain place, an aisle, because that's where the camera is looking. If you put that potato chip packet into a thing that contains juice, it completely fails the system, right? So this is less about the AI because our partner developed the AI for this, but it was more about, as I mentioned to you, the experience of it. And that's why you see within this example, the bounding boxes, right? So there's always a little bit of doubt as to exactly what product was picked up. There's about 95% confidence, but sometimes there's a little bit of doubt. That's where the human comes in and basically says, no, this is the product, right? So you can confirm that. And it's really not for a mom and pop grocery store. I'm sorry to say, this is only applicable for maybe a Costco or big grocery chain that's out there that can actually support this kind of infrastructure. So it's definitely there, but the good thing is that they don't have to have their own data collection model, because then, which comes kind of to the next point, is that no matter what it is, soon find out that developing custom components for every single person is basically unsustainable, right? That's the fastest way to tech that. So you start doing an integration layer, and we accounted for that and put that as part of the design, as in the experience. And like we think user experience only being like the main mobile app that you use. There's about 10 different apps that we end up designing over the course of this, right? Each one has an intended user, and they need to have a certain experience in place, which kind of makes it so that design actually, so it's not just design, but you're discovering what kind of features needs to be present in the system in order to even make it viable in the first place. Forget usable, it has to start at useful. So you start discovering what is useful, and then you basically optimize for what is usable, right? So that's kind of the path that you take. And so going forward, I'm coming up right up to the end of my talk. So I would like to conclude by saying, human in the loop is always kind of number one. You have to account for it because for most applications of AI, ML, or some form of system that involves that automation, the human won't go away. For some, it will indeed, and that's another problem you need to solve for. But most of the time, you live with certain levels of maturity with this balance and struggle between automation and humans. So you have to design it for humans and kind of take it from there, right? So measuring the success and not getting caught in too many customized solutions helps overcome tech debt. And in fact, kind of separating them out with an extra layer in between always helps. And it's always good to start small. Even with the massive scale that I described to you, it started out with the smallest possible experiment, which is actually representative of the real world. Then after learning continuously, much like an AI learns its system and the data, the scaling actually works out. Because I worked with a few others where it failed due to the fact that they started to scale too fast, too quickly. And it basically fails at all levels because from the design phase, even before line of software has been written, that this is just not going to work out because that's what you've discovered, right? And that's kind of why I focused my talk on design today, because the way it's evolving, it's not really apt to call it design system because it's a design delivery system, but it really starts at discovery. And that's when you realize, is this a viable product or not? And how do you actually take it? So that's my talk. I can stay on for a few more questions, or I'll be here for the rest of the event. Thank you.
We have questions from Megha? So how do you design like multimodal?
We actually have an exact thing called multimodal design, in fact. So when you say multimodal, can you just clarify? Yeah. 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 Correct.
This is my voice. This is one, right?
Correct.
Now I reach the store.
Yeah.
The store, because I'm not driving, I can put on my phone. The contact should change. I should not lose the contact.
Correct. Yes.
Then it goes to tell me where to go. That is the mode 2, which is voice and that,
Yes.
then we have the third form, which is what not from the beginning.
Yeah.
How do I make a cake? So
Yes.
instead of somebody telling me, they'll take it to the number.
Yeah. Yeah, it's actually a very relevant thing. So coming back to the retail checkout example that I told you about, right? So you have about like a terabyte of data for any shopping trip, and you have to condense it down to about 10 kilobytes, which is all about I picked up juice, I picked up cigarettes, I put down 2 of my cigarettes, and what is my net, right? Like juice, vegetable, cigarette, and my total is $10. So basically you use that data and you say, do you want to place the order? Do you want to show do you want me to show you where it is within, you went from voice to the Google map or any other app. So do you want to go into that example and show you exactly where that is located, right? So you basically have to use that as a baseline, as basically the object that you're exchanging almost, basically. Yeah. Correct. Yeah. Yeah. 100%. So, design is always content plus context, and people always lose context as the number one thing. It's always there, and that's like the most prevalent problem that we solve. Yeah. Yeah. Thank you.
We do have another tech talk, but if anyone has further questions, you want to take a minute or two with Megha. If not, you can seek me out, and then we have a second. Okay. Thank you.
Awesome. Thank you very much.
Okay, and as I said earlier, this is the way it goes with these kind of tech talks. We could have 3 today. Anybody else wanted to? All right, you can see that. All right, you want to introduce yourself and walk us through a second tech talk. Thank you.
Hi, good evening, everyone. The slides are not completely addressed to this audience. It's an impromptu, but I hope you enjoy the work that's being presented. So my name is Anbu Alvan. I am a recent graduate from San Jose State, and this is one of the research that I took as part of my coursework. And this is an edge case, edge implementation of a deep learning model, where we tried continuous blood pressure monitoring. Specifically, we did it on one particular microcontroller, Arduino 33BLE, and we did get live inference through the implementation. So yeah, the main challenge here is being the blood pressure. We all know what are the challenges that the blood pressure has, or how important it is to keep monitoring of what is happening. And even if 15-minute gap in detecting the blood pressure at times can lead to serious issues. And the present blood pressure monitoring that we have, it's all cuff based, or these days we do have watch based, where we use signals to do monitoring. But these Apple watches or any other blood pressure monitoring that happens in a watch these days, they are connected to a cloud. So if your app is not connected to a cloud, or if there is some delay, sometimes the inference that you gets delayed. And that is what we tried addressing in this research, where everything happens in your device, at the device. And this is also one of the other reason that we tried answering through this is the data privacy concern. Imagine you are a big hospital where you have 1,000 patients whose blood pressures you are continuously monitoring. You can't send your 1,000 patients' data to the cloud and assume everything is safe. Yes, the security is highly improved. We are making sure everything is safe, but there are breaches that we see. So when everything is being done at the device, and you don't have to back up anything to something, cloud or something, then that data privacy issue is being addressed, and that is the main motivation why the edge AI is picking up. Everyone wants to do it in their own device or run their own LLMs in the mobile itself and not send their data outside. So that is the big reason why there is this huge push for the edge AI cases. And the present BP, that blood pressure monitoring that we do, we have this cuff where, it is being attached and it's not really convenient to do it. But imagine you just have a cap that you should be wearing it whole day as you are monitoring, a cap or a ring. We do have rings these days. So if these are all the inspirations why we wanted to do this, and that is what we measured the mean blood pressure, systolic and the diastolic blood pressure, and the data. So the present PPG blood pressure, how we are measuring is we are taking, there is this light that is passed from an LED and it passes through our skin and it is being detected by the photo detector. We have the photo detectors are opposite to the light source or adjacent to it. And these are again two. One is, where is it? Uh, yeah. Yeah, one is transmittive, the other one is reflective. Yeah, in the transmittive, you have the photo detectors opposite to the LED, and in the reflective, you have adjacent to it. And this is how the PPG is being measured. And the present PPG, what we have, we calculate the pulse transmit time and the pulse arrival time. Pulse arrival time is, let's just say you have a signal that is starting from your tip of your finger. It passes through your body and it comes back. That uh, arrival time that it is coming back is what being measured. Same, the similar logic, just a smaller tweak at the PTT. And yeah, so I covered this technical component. I will explain the framework and then go to. So for this experiment, we use the Mimic 4 data set. And in the Mimic 4, there are multiple different types of data that is available. We choose the Mimic 4 waveform database. And in this database, we had close to 198 patients blood pressure for different times. And
For one patient only,
198 patients.
198 patients?
Yeah.
180.
Yeah.
Okay.
198 patients. Yeah, the second point.
Hmm.
So, and these 198 patients, and in this 198 patients, one of the patients joined the same hospital at two different times. That is why we have two duplicates. So total of 200 records we have. And the duration at times varies from 20 minutes to sometime it is there for 72 hours. So there was no consistency, or the duration was not same. So there was a lot of filtering and pre-processing that need to be done. So first thing before going to filtering, we split the whole 198 data. Patient-wise, we split the data into 60-20-20, where the 60% of the patients, not the 60 patients, 60% of the patients is what we took for the training purpose, and the remaining 40 was nowhere involved in inference. And the inference at the initial or the training stage was done on these remaining 20 and 40, I mean, the 40% of the data that we had. So this, since the data was completely a signal. Yeah.
Sorry, good. So usually it's like 80-20 in terms of training and testing. So you're saying that this was
60, 20, and 20, because my data was close to 26 GB and I had huge data and the computing resources were limited. So we put most of the
So 20 were for which one?
60% was for training, 20% for validation, and 20% for the test.
Testing, okay.
I think that's a pretty standard.
Yeah, it goes from 60 to 80, 10, and 10. So the signal processing involved filtering we did separate filtering for the PPG signal, which is our raw data or the X that we have in the data. And we also had the ABP signals of the same patients, which we used in the training stage for the labels. And both were done using the Butterworth filter. Signal processing was done. Then we also had to do the normalization of the signals, and there was also peak to peak alignment that had to be done, because at times what happened, the PPG signals were ahead in time compared to the ABP signal, might be because of the measurement happening at different, or the how the data was recorded. So we had no control on how the data was recorded. We had to work with whatever data we had. Then we aligned our data so that the zero of the first wave or the PPG and zero of the ABP signal aligned. And this had to happen for the whole length of the signals that we had, which at times went to 20 minutes, at time went to 72 hours. And then we also, oh, there is one more. Yeah. So what we did a temporal analysis of this, where first we took 10 seconds as each record in the signal that we had. Then we did the 20-second window, and then we also did the 30-second window. And as you can see, for each signal duration reduced, the number of samples also changed. And we found out that because of resource constraints, where we had to do the inference also on the same data. Let's just say if I'm taking 30 seconds window, yes, I am getting 1874 samples to train, but my inference also had to be done on 1874. And this 187 or the 30-second window of signal had to be sent while inference too. And this was delaying my inference while doing it on an Arduino device. Might be a bigger microcontrollers we could have done faster, but we started with Arduino, and that is where then we found it difficult. It took us sometimes 30 to 40 minutes to get an inference for a 30-second sample. Then we toned it down to a 10-second window, and we whatever results that you see later, these were all done on the 10-second window, and all our training data, validation, and the test data was cut down into 10-second records each. And yeah, this is the data partition that we had. There was different hyperparameter tuning that we did. And the three models that we took were the CNN model, a transformer model, and an attentive BPNet. And these three were taken because it covered the three different spectrums or three different types of deep learning models that were available or that is commonly used in this use cases.
So this BPNet is exactly
It is an attention mechanism model that we have. And the medical standards required us to have the MAE less than 5. So our evaluation was mostly done on the MAE. And these are the different performances that we got, where if you see, we did find out SBP, DBP, and MBP. And most of the times, the models were able to predict the DBP better compared to the SBP, which is the systolic, the higher ones. And it was also able to find out blood pressures in the normal range better. And this could be one of the disadvantages of the data we have, or the limited training that we did. Might be if we do training for 30 seconds and longer duration and use the complete data that we have, might be it would have done better. But right now, given the resource constraint we had, we did it on 10 seconds. And for whatever data we had, the model's performance was really good on predicting the DPB, systolic blood pressure, compared to the MBPs and MAPs, mean average blood pressures. And these are some of the results that we got, where the DBP, as you can see, has mostly done well. It has the mean error, absolute error has always been less for a DBP compared to an SBP and MBPs. And once the models were trained and we evaluated, we took the best performing models that we had, and we did 4 different types of quantizations to reduce the model size. And we did the dynamic range quantization where the weights are in 8 bits, and full integer quantization where the weights and the activation functions are in 8 bits. And we did the float 16 quantization and the integer only quantization. And we did achieve the model size was reduced in few cases by as much as 90%. So yeah, each of these plots that you see, the residual network, the original model was somewhere around 1.4, and from 1.4 we brought it down to as much as 0.13 MBs. And similarly, the attentive BBNet was 5.64, the original model. We brought it down to as much as 0.52 MBs, similarly for the transformer safe model. And the reason why we are doing the compression is the Arduino device that we have. Where is it? Yeah, it only has 1 MB of flash memory and 256 KB of RAM. So we had to bring down the model as much as low in the size so that we have enough room for inference, or when we are giving the input data, it had to run those input data even through it. And when the model size is around around 60% of what is available, sometimes the input itself was there was enough memory to just send the input, and there was not enough memory in the controller to send back the inference. So that is the reason we, yeah, you have.
I didn't want to interrupt you, sorry.
Okay.
But my question is, do you have a photograph or anything of the actual product? 'Cause I'm wondering, is it a system on chip, a chiplet? Is it an AI edge chip? What's the algorithm to use? Sensor and then it drives that.
Like the initial testing inference was done with whatever signals we already had. We sent it through the microcontroller and got back the inference back on the, basically the Python notebook.
It's like bench. It's like a
Yes.
bench concept.
Yes. Yeah. So yeah, if you can see here, there was a size reduction of as much as 91% or 90%, but there was not much drop in the performance of the model. The model performance still remained high. The MAEs were still in the range that they had. And if you can see here, in the case of attentive BBNet, we did reduce the model size almost 91%, but the MAEs and the RMSE mean errors were as good as the original model. So after quantization, there was not much loss in the performance of the models. And the similar trend was observed even for the transformer based and the residual convolution networks. Yeah.
What do you think, can we generalize these like quantization methods for every transformer based? Can we use these strategies in different type of transformer and expect such performance?
Yes and no. The answer is both, because some cases we did find that there is a drop. Some of the models that we didn't include in the result, we did find a drastic drop when it was integer only quantization. We assumed it will do much better in integer only quantization, but that was not the case. So it again depends on use cases.
What was the reason why we were not?
We didn't get into understanding why it was not doing better, or what is the use case. We just wanted it to work in the first case.
So there is no, there are like big companies that doing this type of.
No, every company, in fact, our neighbor Dexcom has so many, it has research doing, and this is like the evolution of AI. Eventually, we assume it is going to be everything available in the phone, and it's already happening. That is of the progresses. And there is huge application of this AI being used in healthcare, and especially in edges where, and I personally feel the biggest advantage of an edge AI solution would be the data privacy. Yes, we are all jumping into using AI in our day to day, but we are not thinking about the data privacy much. We share everything with ChatGPT, but we are not
Right,
thinking
but-
how it is happening.
But I'm
Yeah.
thinking about what's the use case of this. I mean, somebody having, traveling, let's say he's driving, he has a history of, so, he carries your thing and then.
Yeah. The long term goal, or at least my motivation with starting this project, was that uh, I should be able to put it in my watch or just a band, have this device in my band, and it should alert me only when my blood pressure is
Right.
below something for SBP and high.
Correct.
You know, as much as even if it just vibrates for me, it is telling me that your blood pressure is high or low. That
Correct,
should
but-
be
but,
enough
like,
intimation.
now this data, or whatever that alert system need, alerting that thing, it needs to be combined with something else, like, like for example, it should direct you to the nearest hospital, or, like your, how far is your from your
Yes.
personal physician, and those type of computing, right? I mean, this is just computes what's the accuracy of your blood pressure to the data of what you have collected. That's what you are,
Yes.
kind of fine tuned using your model with the 199 patients and things like that, right? But to actually put it into use, you need to respond to that,
Yes.
incident, right? So
It
that
should
you
be
need
able to automatically connect me to the nearest hospital, or at least
Yeah,
show me
exactly.
where the nearest hospital is.
And also, I mean, whatever the limitations of your current model is, because it's an edge computing, you have a very limited capability, right? Again, it doesn't really take into consideration what's your history, for example, let's say, somebody has a 20 years of, blood pressure history, and these pulses, going up and down is a very common, like at least that's what is there. So you don't need to really rush to a hospital. Let's say, if your indicator starts vibrating, saying, oh, your BP has gone, 140, let us say, you don't need to really panic, and then, so you need to analyze, compare your current data with the historical analytics, and then for that, again, your edge won't be able to do that, right? So
It
again,
will be able to do it, just not what we did here, because there is something called as individual calibration that we can do with each of these models, where we send in more data regarding that individual patient. It is similar to what we do when we get a new smartwatch. We give it more data about our age and all those details, so that it knows what is the normal range. It adjusts the normal range accordingly to your age, weight, and height and all. Similarly, here also we can do that. It's a future application that we can do it.
Just want to call about the innovation on the edge. How can we go in next few years, we have a quantum chip in the area of research, because we actually have a quantum chip, it can be a lot of information, right? 5 to 10 years.
Yeah, we can do that. Even now, there are bigger chips that we can do it. But frankly, we don't need to do it right now, because in this case, we train the model on a GPU model and then put the quantized model on a chip. So it doesn't matter if we are adding more data, just that we didn't have enough compute resources to do it. But we can do that in the future.
but even that quantum chip is not going to solve your problem with privacy, because you need to send that data out of your edge, right? Again, at some point of time, the long-term analytics or whatever, right? Are you going to create a model?
So the goal here is the privacy, that is the. So right now, because history of there is not, there is a similar model, one can do blood pressure, heart rate.
Yeah.
Combine all this model and.
Yeah.
What we can do. But the data of computing person like people go ahead. I think. And Microsoft and Google, they already have chips.
Yeah.
I don't know.
There's another model where you could use it as treat it as an edge device, where like you're just much. You don't do any compute, you just obfuscate the data.
I try to do that, like, this is a very high tech, but low tech, you can buy a negative spot, you take the time out from the zone, and then you just do it. You just tell you your blood pressure and you take the data and then. That's it. And you will not know where the data came from. But there are ways to.
Yes.
Yeah.
But you get sensors which are even more pocket friendly.
Yes.
Yeah, actually, there are a lot of these things. This all comes under what they call the pragmatic, right? And PPC, right? Privacy preservation, MPC, multi-coding, upcoding, all these things you get. Again, it comes to privacy preservation.
Yeah.
But it's a big thing, right?
Yes.
Yeah, I have a question regarding the models you trained. So those models, you trained all this data on models that are specifically about measuring blood pressure? Or how did you decide what these, what models? to use?
We used all the three, like I said, we used an attention mechanism used and the transformer based model and the convolution. These three models were based on existing models which did well on blood pressure monitoring on a bigger device.
The original models under these architectures were already fine-tuned for blood pressure.
There was no transfer learning done. We anyways had to do it, but the inspiration was from existing models that were already there, which were trained on blood pressure.
Oh, and you built on top of
Like I said, there was no transfer learning done, so we had to build from scratch. It was trained from scratch, but the idea of using an attentive model and a transformer model was from the existing research, which gave better results in the field.
So you used the architecture, but you didn't
No,
use the parameters.
no, because they
Why
are
did you, like, what was the
they are
reason?
just not available. That would have been easier. It would have reduced our resource necessities because all we had to do was a transfer learning and retraining, but we just didn't have those weights.
Privacy thing. That is,
Yeah.
all these.
But then these are real world applications. Even I don't have my model publicly available.
Oh, yeah.
Yes. So yeah, right now our limitations are that these are done based on the 198 patients that we have, where we did a five-fold training of these 198 patients. But these are not so like he just mentioned. These are not individually trained, or there is no individual data that is being ingested. If a patient has BP record or not, we are not aware of it, and that was not involved in it. But in the future, we can do it. And since most of these data are sensor based, there is always the issue of motion stability that we will have to consider. And there was a lot of resource constraints, especially when it came to the microcontroller. We tried from the whole first we tried taking 1 minute data, then 30 seconds data. Some of even when we took the 1 minute data, even the deep learning models that we trained didn't give us good performance. Then we had to cut down to 30 seconds, and that is where we tried different iterations or different hyperparameter tuning that we did. And the future, there is a lot of potential for this project, and not just this, any edge healthcare related, there is a lot of potential, mostly in terms of the data privacy and the quick inference that we can get. We did get inference which were in milliseconds. 2.3 milliseconds is the best inference that we got for our use case, but it can even be reduced further when the training is done better or more longer. Yes. And this paper was also published on MDPI recently. Thank you.
Further questions? Someone had a hand up.
Yeah.
Yeah, one thing I was wondering, is that the hardware is a pretty periodic signal.
Yes.
And could you not just align one pulse, which is like 1 second of data? Or like basically, you can take 16 pulses, align the pulses, and then overlap them.
The SAM,
Create a signal that is just 1 second long.
yeah, we can do that. The sampling rate of the signals that we had was 62.47 milliseconds. So we did, we can do 1 second, but we got decent enough results with 10 seconds that we had, that is having much bigger data. But we could have trained it for 1 second or even done with 30 seconds. Just that since this was a training attempt, we just wanted to first get the application done.
You had significant improvement from, was it 30 seconds?
Yes,
originally?
30 seconds.
10
We
seconds.
30 seconds, we brought it down because we were not able to get the inference on microcontroller. But might be a bigger microcontroller that if we were able to use it, we could have done even that. We could have gone with whole 1 minute. Yeah. Thank
Any
you.
other questions? Well, thank you. Thank you to both
Thank
of our
you.
presenters. Thank you for volunteering all of the last seconds. That's awesome. I actually thought of something that Google released. We're not sharing anymore, so let me pull it up real quick. Loss of pulse detection. Watch 3. This one. Yeah. Come on. This was the one. Not exactly in the same vein, but something very relevant is back in August, Google's Pixel Watch 3, we made this announcement, and it's been available. It was approved by CE. It's been available outside of US in EU, kind of since around then, and just recently, you can see February 26th. Yeah, it was cleared by FDA, whatever reasons, right? But this is the kind of an adjacent use case, right? Like yours is, I think, actually even more complicated. But what brought it to my mind is this graphic right here, right? No pulse detected, calling 911, right? And this is very similar to, we have a fall detection algorithm, as well as a vehicle collision detection that it will set off. So this leverages kind of that same mechanism. I forget who it was that made the mention of like, connect it to 911, right? Or tell me how to get to the hospital, whatever it was.
Super scary when you go skiing
And you do. I have not experienced that, but I would be scared, yes. Yeah. So yeah, if anyone's interested, like I won't make you sit and watch a YouTube video here in a room with all these people, but check it out. Kind of interesting. There was, I think this is the blog post that, yeah, this one talks a little bit more in depth, and actually goes into, I think it's that graphic, kind of some of the. This is Edge. This is being done on the device. Yeah. It can, you can connect up into the cloud, and someone made the very correct assertion that HIPAA or PIPEDA, or depending on where you are, your different compliance regimes absolutely factor into how you're designing your models, where you're placing that data, and that was a little bit of part of what I was showing you in the model garden inside of Google Cloud's console. So we published a public list of all of the services. There are many in Google Cloud by compliance regime. So whichever regulatory body, if it's US HIPAA, you can have a BAA if you work in health, you know what a BAA is, for storing your HIPAA data inside of Google Cloud, and the way in which you use those services to meet your obligations, and leverage the levers and buttons that you should to protect user data in that way. And that's similar what Google does with both our consumer devices as well as for enterprise on Google Cloud. So some of these things could be hybrid, they could be connected, or certainly developing for edge type things like this as well. So very cool presentations. Thank you to both of our presenters. Hopefully, if you're noodling on an idea or you got a little spark, this moves you closer toward presenting maybe next time or the time after next time. Thank you for our second presenter who was not on the docket and just stepped up and delivered. I think was a good complementary, another application of these types of technologies. So thank you very much to both. I think that's all we had for today. Did anybody have anything that they thought we were going to do or you hoped we would do? Oh yeah. Uh-huh.
Like emergency call, and what happened next? It just like, what does it say? 911, no calls detected, or what is now?
Yeah. I think, let's see. Yeah, that one does not, it doesn't show it in that thing, but just like on your phone, you probably know this on your phone, if you dial 911 and you're non-responsive. Uh-huh. Right, yeah, I haven't either. But if you call 911 on your phone, it also sends additional metadata such as your location and a few other things. So I believe in one of these write-ups, it talks you through exactly what that is, and there actually is a Google Help page, because this is a Google consumer product. We document all that stuff, like what does happen. Don't just try it. Don't die on purpose. Just to test it, please. Even momentarily. But yeah, I think it transmits that information, and obviously, like if you get your pulse back and you're like hello, but if you're not, it's at least able to transmit something about you and some of the situation that we think you're in. Hopefully none of us have to test that, but I'm glad we're building stuff like this. It's really cool. Cool. All right. Well, I don't have anything else for you guys tonight. It's 7:05, so we're pretty much on time. Feel free to hang out for a few more minutes, connect with people that you wanted to meet. Get your LinkedIn connections, other things like that. Also, don't feel obligated to hang out if you're done. That's fine too. And we'll close out probably another 15-20 minutes. Awesome. We do have another meetup coming up next month. Look on the meetup site, do the AI Camp registration, and we'll see you there.